That accidentally ended it too. Oh. Thanks, Olivia. I'm kidding.
How is that?
You distracted me.
Sorry.
Please remember that in front of the A, there should be a negative sign when you write this. Because one of them is disappearing and one of them is appearing. If you're disappearing, there's a negative sign. If you're appearing, there's a positive sign. We just typically leave positive signs out. Times, yeah. Sorry. Just means multiply. I hope you guys really enjoy how bad I am at this. I don't know if you've ever watched the class videos, but I'm like, I don't know. I mean, I post them. Yes. And then I post them on your Canvas.
Why do you lock the comments?
Yeah, why do you lock the comments?
Because I don't care for comments.
What if they're like
At least it's the dislikes.
Say again? What'd you say? What does the C? Respect. With respect to. You'll hear this terminology a lot in this particular chapter. The with respect to means compare the two. Right? So it just means compared to.
Wait, so is that the answer?
Yeah. That's it. This is what you should have written. I was looking for you to compare just two of them, not all four. And I want you to realize that this can be interpreted so that you can just look at for the rate of one, you can look for the rate of one with respect to another, you can write all of them together. Bless you. All right. So another thing that we can look at is how does rate change with concentration? So this is where we can do experiments with different concentrations of reactants to see how the rate changes with respect to just concentration. So we're walking away from the idea that we just put it in a beaker and monitor it to now let's do experiments where we set it up so that different concentrations are what we're going to start with. Okay? And there is a reason to do this. So here we have an equation where we react two things, ammonium, and nitrate. When we react the two, what we do is several different experiments. Here we did 6 experiments. You see that? In each of those 6 experiments, we started with a different amount of the ammonium or the nitrite. And you're given what those initial concentrations were. You're also given the observed rate. So you did all these experiments, you started with these different concentrations, and you measured the rate of the overall reaction in the far right. Okay? Here, this type of data, what we're going to do is we're going to try to compare things that stayed the same with something that changed predictably. So for instance, in experiments 1 and 2, oh wow, that is way off. Cool. In experiments 1 and 2, what happened to the concentration? How did it change? It went up by a factor of 2. If you take this one, you multiply it by 2, you get this, right? Okay. Over here, what happened to the concentration? Stayed the same, right? So no change. On the far right, we have an observed initial rate that changed from 5.4 up to 10.8. What's that? How did that change? Multiplied by 2. With this information, we can say that when the concentration is doubled, the rate doubles. And this specifically references the NH4. So when the concentration of NH4 doubles, it affects the rate by doubling the rate. So now we know how one of our two reactants affects the final product, or affects our final rate. The next thing we want to do is figure out how the other thing affects the final rate. In order to do so, we need to find two experiments that change the rate of the second one predictably, and that keep the other one the same, just like we did for this one. So here we have experiments 4 and 5. What happened to the concentration of the NO2? It doubled. 0.0202 to 0.0404 doubled, so this went up by 2. This did not change, so this is a viable set of experiments to look at. And then we want to look at what happens to the rate of the reaction. What happened to the rate of these two experiments from here to here? It doubled. So, for NO2, we can write that when the concentration of this one is doubled, the rate doubles as well. This information translates into how to write our first rate law. Yes?
If both things were doubled, would that quadruple the reaction time or bring it back down to?
Not necessarily. So where we're going with this is to be able to predict what we call a rate law. And we'll talk more about it tomorrow.
I was on